All right, here we're going to go ahead and finish section 11.3, and we just had a few things left here to discuss. And what we need to look at here is something that's called the derivative. And the derivative basically is this process that we're going through with the difference quotient and the slope. So finding the slope of a graph at any given point xy, it is the derivative of the function. So the derivative of f at x, where again x is just coming at a point, is this. This is the symbol for derivative with the little accent mark there. That's derivative. The limit as h goes to 0 of the difference quotient. All right, let's look at derivative. So we're going to go through here. We have some of the similar examples that we did here just recently. So let's go ahead and just do the derivative. We've got f of x plus h minus f of x divided by h. And when I do this, I'm going to have x plus h squared plus 5 minus x plus h, or minus the original function, which is x squared plus 5, all over h. So let's go ahead and FOIL and simplify some things here. So that's x squared plus 2xh plus 5 minus x squared minus 5. You got to distribute the negative over h. Combine my like terms. My x squareds cancel. My 5's cancel. I have 2xh over h, which equals 2x. We also have our h squared in there that needs to be accounted for. We have our h squared that should be right in here from the foiling, and so that would leave us, if you divide them both by h, 2x plus h. So we're looking at now the limit as h approaches 0 of 2x plus h. So if you substitute 0 in, then it's equal to 2x. This is the derivative. And what the derivative gives us is the slope at any value x. So I don't have a specific number I'm going to put in this time. So this represents all slopes of the tangent lines for that function at any given point. All right, let's go ahead and look at the next example. So we've got f of x plus h minus f of x over h. So let's substitute x plus h. So it's 3x plus h squared minus 2x plus h minus the original function, 3x squared minus 2x, all over h. I'm going to FOIL. X squared plus 2xh plus h squared minus 2x minus 2h minus 3x squared plus 2x divided by h. I'm going to distribute the 3x squared plus 6xh plus 3h squared minus 2x minus 2h minus 3x squared plus 2x all over h. And let's start canceling some of these parts out. The 3x is gone. The 2x here gone. I am left with 6xh plus 3h squared minus 2h divided by h. I can reduce them all by h. That's 6x plus 3h minus 2. Now, back here at the top, the limit as h approaches 0 of 6x plus 3h minus 2. See, what this equals is 6x minus 2. So this is the derivative. All right, one last problem here. So we've got to do my difference quotient. So this would be x plus h to the fourth minus the original function of x to the fourth. This equals x plus h. I'm going to do squared and x plus h squared. We'll worry about foiling all those out again. So if I FOIL the first one, it's x plus x squared plus 2xh plus h squared. I've got that twice. Minus x to the fourth. Again, this is all going to be over h here. I've kind of left that out for right now. Distribute here, so x to the fourth plus 2x to the third h plus x squared h squared. That's the first term times all three. Now the middle term times all three, 2x to the third h plus 2x h squared. Actually, that would be 4 x squared h squared plus 2xh to the third, and then the last three would be plus x squared h squared plus 2xh to the third, and then plus h to the fourth and minus x to the fourth. Let's go ahead and simplify all of these. Here there's a lot that I can combine. I can get rid of my x to the fourths. I've got a total of 2x to the third h and 2x to the third h. That's 4x to the third h. Gone. I've got 6x squared h squareds. Those are gone. And 4x h to the thirds. And h to the fourth. So again, this is all divided by h. If I reduce them down, I'd have 4x to the third plus 6x squared h plus 4xh squared plus h to the third. Now, the limit as h approaches 0 then of this, so I can find the slope. If I put in zeros for all of these, this is all 0, 0. My answer, 4x to the third. Final answer. That's the derivative, again, which represents the slope for any given x on that curve. And here's your assignment for this finding the slope of the tangent line in derivatives.